Why am I doing this talk? So I'm a consultant with Riverpoint, and a lot of the work that I'm doing right now is helping people onboard Terraform, onboard Packer, and also helping out with Kubernetes solutions. And usually a lot of the use cases that I hear when it comes to Kubernetes is that it's very complex. And so for me, I was thinking, well, what's an easier solution out there? And since I already work with HashiCorp products, I'm like, let's give Nomad a shot. So I put in this talk. I knew nothing about Nomad. And so I challenged myself to say, within 30 days before the talk starts, let's develop a solution. So here I'm today. So taking 2 words from my talk, the first is going to be journey. I'm going to talk about where I started in IT. IT wasn't my first job. And then also I'm going to talk about self-hosted and why I'm going to focus that during my talk. And so when I was trying to practice this, I was thinking of Journey, and I was thinking of Statue of Liberty, and specifically a quote on the Statue of Liberty. And part of that quote, poem is, "Give me your tired, your poor, your huddled masses yearning to breathe free." And I'm trying to think of how to put this more in context for HashiCorp, so I put something and mixed it up a little bit for how Hashi is when it accepts people that are sysadmins, that are struggling, that have to put out fires every single day. So I'm going to change this up a little bit. So give me your sysadmins, your scripters, your ClickOps engineers yearning for better processes. And I think when you're on IT and at least a sysadmin, the first ways that you try to automate are usually with scripting, so PowerShell, and essentially, I won't say savior, but the process for me that made it a lot better was Terraform, and it's just, yeah, now I'm up here. So as I mentioned, I didn't start in tech. I didn't start in IT. 2015 was my first tech job. I was working with a small but growing regional airline. So a lot of the processes there is when I was like, I need to find out a better way to do this. There was heavy toil during the job. So I was learning PowerShell scripting, using it with Office 365. Whenever new employees would be onboarded, it was a simple process to onboard them to our mailboxes into AD. Fast forward to 2019, I'm now working with a software company. We have a privately hosted solution. New customers would get onboarded. The time to turn around those new customers from purchasing the product to getting them onboarded to our hosted solution was about 3 or more months to put them into production. Luckily for me, a friend and a coworker in 2019 flew out to Seattle, went to this conference called HashiCorp. He's here right now. Hi, John. And brought back a solution called Terraform. And what's wild is a product that I started using has changed my life significantly, and I've made a career out of it. Looking at self-hosted, so my background's self-hosted, working with vSphere, my own lab equipment. So other reasons for why I'm focusing on self-hosted, this could be company policy. A lot of companies don't want to send their customer or their own internal data out to public solutions. This could be regulatory compliance, that could be HIPAA, PCI, FedRAMP if you go into those situations. And then lastly, bare metal. A lot of companies already invested on the infrastructure and the equipment and the manpower, so they want to use those existing solutions that they already have. I'm not used to these clicker things. There we go. So for my agenda, go over quickly who I am, what's my end goal, what did I try to build out, why did I choose Nomad over other solutions, and then lastly, I'll walk through the processes of developing, implementing, and then scaling that solution. So based out of Ohio, specifically off of Lake Erie. Originally wanted to be a teacher, but then moved into tech, so there was 6 years of college that I wasted and still paying off right now. And then lastly, I'm into retro gaming, something I picked up during the pandemic, but then prices for old systems got very expensive and became an expensive hobby. When it comes to tech, I mentioned Terraform, Packer, CI/CD, and any kind of orchestration tool, whether it's Kubernetes or a cloud-hosted solution. I work with Riverpoint. We are a HashiCorp partner, and just showing off some of the recognition that we've had over the last couple of years. We also have a booth here, so if you want to talk more, you might be able to catch me at the booth or any of the other employees that are here. So moving on, what's my end goal for the talk? So a lot of the work that I've been doing recently are solutions called image factories. I'm not going to go too in depth of what an image factory actually is, but a common solution or issue that I see with image factories are that a lot of the solutions need to be self-hosted since they need to be private and within private subnets. So my decision was to use Nomad as the engine to run my image factory. So HCP Terraform Agents, if you're running that, you can run the agents on Nomad where they can scale out, run internally. I'm using GitHub Actions. They can scale out in there. I'll go a little bit more in depth on how I do the scaling. But if you are interested in what an image factory is, here's some links. The first one is an older talk from HashiCorp. It talks about the process of what a golden image factory is. And then the next link is from a talk last year at HashiConf about managing golden images across multiple platforms. Some constraints with my talk, or with this, and I wanted to keep it simple, so I leveraged the hybrid approach with it. So I do use GitHub, the SaaS solution, but then the runners are going to be within my private subnets. And then lastly, it's going to be free-ish. If you have your own equipment and say vSphere as a solution, you can build this out for free. If not, if you use a cloud solution like AWS, you will have to pay a little bit for it. So moving on to why did I choose Nomad? So the first thing is simple, and it's the common use case that I hear with Nomad compared to Kubernetes. It's a single binary that you download, a simple solution that you've set up on the server. It takes a few minutes to get set up. The next is lightweight. It's a lightweight solution. You can run it on most of your hardware, and then you can move it into the cloud, and it won't take up too much compute, so you can focus more on the applications and processes themselves. And also, when it comes to storage, it has a lightweight footprint. So the last I checked, it was around 100 megabytes. Taking you back, this is a zip disk if you're unfamiliar. I think most people are familiar what a zip disk is, but at this point, it's legacy tech. This was a big deal back in the day. Third reason's agnostic, so I needed a solution that I wanted to be able to develop on my laptop, move into the cloud, or move into my on-prem solutions. So Nomad's a good solution because you can run it on most major OSs, so Mac, most major Linux distributions, and lastly, you can run on Windows. That same binary that you run on your laptop, you can also run on your on-prem solutions. And then lastly, when you are ready to migrate into the cloud, you can take it from on-prem into the cloud. So you can develop the patterns locally on your laptop and then move them on as you progress up. And so now I'm going to show you why I'm actually wearing a fanny pack. So when I first started to build out Nomad, I decided, let's try some old infrastructure that I have at the house. And when I say infrastructure, it's more so this junk that I carry around that my wife keeps telling me to get rid of. So the very first part of my Nomad cluster is a 13-year-old Lenovo laptop that doesn't have a hardware cover or hard drive cover on it, so I can swap out the hard drive if I want. This was able to run Nomad. And then this is why I have the fanny pack. The next piece of equipment, if I can get it out, is a mini computer. So if you're familiar with Intel NUCs, this was the second server. I feel like a bad salesman up here, but this is the second server that I set up Nomad on. And then lastly is probably a device that many of you are familiar with. Little Raspberry Pi, I think it's 4th generation. This was able to run Nomad. So when I'm saying agnostic, it can run on many OSs, and it can also run on new or old hardware. Find the clicker. And then moving from the technical reasons, there's personal reasons on why I chose Nomad. So I mentioned that I formerly was a teacher, so my background's in education. There's a theory of scaffolding and strategy. Essentially what scaffolding is how you progress as a learner. So first you learn addition, subtraction, and multiplication, and then more complex math topics after that. And then to visualize this, the unaided, this is concepts that you already know. When you start to learn and develop, that's where you get into the guidance layer. And then lastly is the cannot do. So no matter what guidance or assistance you get, you just can't solve it yourself. And how this relates to me, so the first solution that I've worked with was Terraform, uses HCL. It was something easy and comfortable for me to get into. Next was Packer, used HCL as well, so I was already familiar with it. It was easy to pick up. And so lastly, Nomad, when you run job specs, the configs that use HCL. So if you already know HCL, it should feel familiar. I'll show examples of Nomad later on with the configs. It'll look very similar to what you already know. And then the next reason's time. When I first started in IT, I had many hours in the night to pick up new solutions, to sandbox them, to test them out, to study. And at this point in my life, I don't have the amount of time, maybe like 30 minutes or an hour. And probably for a lot of you here, it's a similar reason why you don't have as much time during the night. for me personally, mine started in 2021, and there's two reasons. The first is my son Reese. He was born in 2021, and then next was Joel, who was born this year. And thank you. And if you're a parent or caretaker, you can probably have the same feeling. At this point of my life, at least, when it comes to my development, sorry, I'm getting like emotional, takes a back seat to my own children's development. So that's why I don't have as much time. And whenever I build out new solutions, it needs to be something familiar and that I'm comfortable with. So moving on, so I'm going to show you the solution that I built using Nomad with the image factory. So for each section, I'm going to talk about the objectives of what I'm going to do and then review the objectives. So for this, I'm going to plan out what necessary tools and resources are for the image factory. Next, I'll run it locally on my laptop, then build out my custom runner, and lastly, deploy it to my local laptop. So for the tool chest, Packer, and then HCP Packer, I'll send the metadata to. Terraform is what would consume the images that I create. GitHub will be my source control. You can use other source control software out there. GitHub Actions is going to be for my pipelines, and then lastly, Nomad will be the engine that runs everything. For software that I'm excluding, Vault and Consul, these are very common when it comes to building up Nomad clusters, but in this use case, you don't need to know either of those. And then for platforms for building my images, AWS, Azure, and vSphere. AWS and Azure are going to be built on private subnets, and then vSphere is literally in someone's basement. And then for the hardware that vSphere is running on, it's 3 Intel NUCs, so it's a pretty light in terms of compute. So pretty much showing that you can still run this solution on any hardware. So when it comes up to setting up Nomad locally, pretty quick and easy. If you have a Mac, you can use Homebrew. If you have Windows, you can set up with Chocolatey. And lastly, if you have a package manager, you can use that to set up Nomad. In my case, it's 3 simple commands: brew tap, brew install, and lastly, the Nomad agent dev to set up a development server. Once you move on from that, you can use the Nomad UI. You can access it locally in your browser via the command line, and you have your Nomad development cluster up, and you can start developing on it. Since I have my Nomad server up, I will containerize the runners. Just some pros and cons before I go into how I set that up. You can limit the packages and what gets installed on the runners, so you can customize them. Since you're putting them in containers, they can scale out. And lastly, these are ephemeral. So every time a runner runs, once the job's complete, it will automatically destroy itself. And then Nomad would orchestrate by creating a new runner off of that. Some cons with it: it can get heavy depending on what you install on it. This is kind of a lift and shift. There is a Kubernetes solution, but for this, it's lifting and shifting for what would be typically on a server. And then it's not really a documented process. Most of the learning that I did was from blogs and what other people did. And then this gave me another opportunity to use Packer. I never used a Docker plugin with Packer. So pretty simple, and if you're familiar with Packer, it's going to look similar to building servers. So here I have the source block. I'm building off an Ubuntu source image, and then I'm specifying which user account to run it on, and then also the entry point, which will register, essentially run a script to register it with GitHub. The next, since this is running in Packer, I can run scripts or file provisioners on it. So for this, I'm executing a script on it. This will set up the runner with all the necessary dependencies and also sets up Ansible on it. So when I do my Packer builds later on with the runner, I can use Ansible playbooks that you might already have to build out those images. Then with the registration, I copy over a file to make it simple and to dig into what that file looks like. The first step is I'm passing over a GitHub token. It will grab a registration token from GitHub. The next thing it will do when it starts up is configure the runner. You can customize what repo to assign it to, the name of the runner to make it dynamic, the labels. So when you have a pipeline, you can specify what labels to pick up in that pipeline. And then lastly, I set it up as ephemeral, so it will delete itself. And then lastly, when the container goes up or if it fails, it will clean itself up from the repo. The last step of building out the container is to tag and push. So there's a post processor. Once it's completed, it will tag and push it into my private registry. So moving on, this is Nomad. If you're not familiar with what Nomad is, it's going to look similar to other HCL. For this, it's a relatively simple service that I'm getting set up, and I'll just walk through the steps of it. So for this, it's a service, and how that works on Nomad is it will ensure that this service is running within the cluster. The next thing is the group. So for this, I'm only specifying one for now. I can specify the ports. I'm using this dynamically. This is specific for my vSphere builds. And last one on this page is config. This is us pulling over the runner image that I created and then passing in that port and specifying the network mode. So with this, it will use the host networking when running vSphere builds. For environment variables, I'm getting these passed in. So one thing to note is the name. I'm dynamically pulling in the allocation IDs, so there's no conflict with the name. And then I'm also passing over the HTTP port as an environment variable that Packer can pick up. And then lastly is the template. This is the way that I sent over my GitHub token without putting it into plain text. I use what's called Nomad variables, and when talking about Nomad variables, context does matter. So Nomad variables, as I learned, aren't always the same thing as Terraform variables, and then Nomad variables aren't a solution to replace HashiCorp Vault. So if you are putting this in production, you might want to look at putting Vault up as well. So this is a variable that I set up and how I set it up. Every single job on the cluster would have access to it. This is probably too generalized, but you can also restrict it down to a specific job as well. And then once you're ready, you can have the job running. And then for this test example, you can also, within the UI, access the logs of that container. So you can see here, it spun up, and then it successfully registered within my GitHub. So for this development stage, everything's set up. I planned out the tools, ran it locally, and then built out the runner and successfully ran it and deployed it. So moving on to building out my image factory, I'll provision to my 3 platforms with simple Nomad clusters. I'll let you know what simple Nomad clusters are, because that's not an actual term with Nomad. I'll write in my base and layered Packard templates. And lastly, I'll run my Nomad image factory within my pipeline. So manually building each server, when I say simple Nomad servers, essentially I'm running them as a server and client together versus splitting them off. In each platform, I'm running them as a service. I'm bootstrapping the cluster since I'm not using Consul. And lastly, I'm making sure Docker's installed so the containers can run on it. And then with these, there's no public access from the internet, so they are communicating out via NAT. Next step, I installed observability using Datadog. There's existing integrations within Datadog, so you can send any of your cluster data or container data to the cloud as a single pane of glass for that. And once I have the platform set up and the runner set up on my Nomad clusters, they got registered, and each one here, you can see I have labels specific for vSphere, AWS, and Azure to those specific environments. And then moving on, so for my actual image builds, pretty simple setup that I got. It's a couple of base images, RHEL, Ubuntu, Windows. Next, on top of those, I build out Docker and Nginx images. And then lastly, off the Docker image, I create Nomad images. So this is what it would look like when I'm layering the builds all together. I actually see people taking photos. So that's a good thing, I think. To tie those together, HCP Packer makes it simple. So instead of having to know the unique ID for each image that gets created, I can reference it with a data block. So once the image build is complete, it sends that data into HCP Packer as a single registry that you can reference. And in my case, I broke it out a little bit too much, but there's a reason why, and I can talk more later about that after this. But I have it specified for each platform. In the real world, you probably can have a single Ubuntu bucket that you reference, and then you reference the platform off of that. For the workflow, this is a part of my GitHub Actions pipeline. So a couple of steps on it. So what you originally do is you select what images and platforms you want to build on, and by default, it will select every platform, every image, and then off of that, it has a dynamic, essentially a matrix to do a build for each of those images. The next thing it does is it will pass over a couple environment variables, so to the Packer template itself, depending on what was selected in the pipeline. So if it was AWS Ubuntu, it would send that down for the bucket, and then the platform would get pushed down as well, and I'll show why I pushed those. And lastly, the strategy. I decided to do fail fast as false, so if a single build does fail, it doesn't fail all the other builds. Really, the only reason I have for this is, say, if a security patch or a fix that needs to get pushed out, I want to ensure that it gets out to as much as possible. And then within my build template, I'll show you why I'm passing down those variables. So the first is platform. I'm picking it up as an environment variable. And then from that, I'm grabbing it in the locals, and I'm specifying which source to build it off of. So if it was AWS, it would pick up the Amazon EBS Ubuntu. And then lastly, from here, I was using the local build source. And essentially, this was a workaround. So if I was specifying only a single platform or a single build, it was causing issues with my bucket. So this was the workaround that I set up for that. And I'm going to do a quick demo of what this looks like. So this is the base without the scaling Nomad image. So I kicked off, run manually in the background. And then from here, what it does is it will build each image. And this is vSphere specifically. I'm showing that the dynamic port that was set up by Nomad gets passed in, and then also the host IP gets passed in as well, so that if you have user data or a kickstart file, it can properly get picked up. This is the Azure example that's spinning up, and then lastly is the AWS example. And by default, AWS would try to build it on a public subnet, on a public IP, and here I'm forcing it to build within a private subnet. And then 2 notes from the results. The first thing is to make sure you aren't always triggering runs on every single push, so you'll end up building way too many images. So in this use case, this ran 113 times by the time that I caught it. And then the next thing, just for these 9 images, since each runner had to wait for one build to be finished, it ended up taking 35 minutes. So this is something that we can improve upon. I'm going to just speed through this. So I have a factory, now I want to expand the factory so it scales out much more dynamically. A couple of options that I explored when it came to scaling with Nomad. Essentially, the simple options to start out was a system scheduler, which would put it out on every single node that you have defined for it. This is an overkill solution, was too static. The next is the scaling block. So if you had end users, op users, that need to scale up a solution, they can go within the UI and scale it up. You can enforce whether it's a minimum of 1 and up to a max of 3. And then lastly, you can also use Terraform to interact with the cluster, but I didn't do any demos with that. The next is an autoscaler. Essentially what the autoscaler does, it's a separate service that runs on the Nomad cluster. You can check it on YouTube. There's examples of how the autoscaler works. And it's the reason why I set up Datadog on the nodes and in my cluster itself. So essentially what it does is that service will check Datadog. It will say, what's the memory usage, and check the average of that. And if it hits the threshold on that, it will decide whether to scale up or scale down. This is the target value that I set up, and Nomad will reference that and say, OK, you're at 1.5, so I'm going to try to scale you up to 2 so we have that extra room. And then the scaling block here is now limiting how much and how little it will scale down. So by default, it would try to scale up based on the factor of that target value that was queried. But in this, you can prevent a service from kind of overrunning your cluster. And the last thing here is the policy. So this will talk about the frequency of how it will check, and then also the cooldown, so it's consistently not scaling up and scaling down. So this is a quick demo that I did with the autoscaler. So on the right is the autoscaler service that's running in a container. Essentially what it did is it queried Datadog and saw that it was above that threshold. And then on the left-hand side, which it already finished, it decided to take action and scale up my GitHub runner to a second container. So I went from 1 container running my GitHub runner to 2. And this last option is the unique option. So this is using what's known as a Nomad pack. And essentially, if you're not familiar with Nomad or Nomad packs, I think of it as more of like Terraform modules. It allows it to be a repeatable process. Instead of pushing out a job specifically with variables, you can push it out as a template. And then In this situation, instead of having a dedicated GitHub runner that will do the Packer builds, I created something called a GitHub listener. What it does is we'll listen to GitHub when a build or workflow kicks off. It will say, hey, I need to scale up. It will create a specific job for that build, and then once it's done, it will clean it up. So I do have an example of what that looks like. The other thing I want to note is instead of running this as a service, I'm doing it as a batch. So what happens here is it will run, and then if it fails or finishes, it will go down, and Nomad won't attempt to bring it back up. Pipeline itself, the only major thing that changed, so since I'm creating a specific job for each, I had to put on a additional tag for the runs on. So it will look for the runner that is for AWS, Ubuntu, and then that specific run ID that it was triggered from. And then environment and strategy were all the same. So with that, I got the listener set up on each cluster, ready to go. And I do have a quick demo here. So a couple more steps. So the first thing, select which images to build off of. The next step, that listener will take that request and scale up and create a unique job. And so from here, you can see now every single build that I requested is now going through. I do promise that, well, there we go, does pick up. And so now every single one is running. And I'm actually going to let this sit to give myself a break, and we can just watch it work. Yep, and each one's like a unique runner for each of those jobs. So whatever you're built and whatever data is getting pushed to, it's only running on that container. I do get a little bit antsy and check to make sure something's running. But these do finish up here shortly. And then I have a final step, which is cleanup. So once the jobs do finish up, whether they're successfully or not, this last step, which cleans up, will make sure those jobs are destroyed on the cluster. So anything that ran in those jobs will be fully deleted. So from that, with that last scaling action, I'll say the unique one is kind of uncommon. You'd probably see it mostly with like the Kubernetes. Kubernetes has a controller solution with GitHub. So I was trying to build out something that was similar to that. But for the outcome, the original run that I did was 34 minutes long. With the scaling, it brought it down to 20, so it was about 13 minutes of time savings. But once you start adding in layers for other Packer builds or more frequent image builds, you'll see compounding time savings with that. Then cut for time, something that I really want to do is continue to build off a golden image factory. So not only build the images, but then find a way to test those images. If those test out successfully, whether it's security or some kind of user testing, automatically promote those images in HCP Packer. So if it's the latest image, promote it to the production or development image. You can use that with Terraform. And then lastly, go through with the provisioning steps of how you can provision those images. And then HCP Terraform Agents, I was going to showcase that of how to scale it up and scale it down. This ran out of time with that. But essentially with the agents, you can run HCP Terraform, but if you do have private networks that you need to build in, those are an extension of your HCP Terraform. And lastly, kind of my dream is to, and something I used to work on was Terraform Enterprise. I want to try to build out a full Terraform Enterprise solution on a Nomad cluster. So in conclusion, this was a simple process for me. It took 30 days to build out. Lightweight, I was able to run on most of my hardware that I had. Agnostic, ran on multiple platforms, OSs. And then lastly, this was a solution that I was able to scale out. I'd probably say the auto scheduler service is the most practical, but you can do other things to interact with the Nomad to help it scale up. And so if you're interested in what I built out in some of the Packer templates and Nomads, I'll probably keep contributing to this, but I do have the Nomad image factory that you can check out. And then I'm also going to go a little bit more in depth on my blog. So I already have a few posts right now. Got a little bit tied up this last month and didn't get them out, but go a little bit more in depth of setting up those Nomad clusters and giving more technical examples on them. And then there's some acknowledgements. Drew Mullen, as you can tell, I'm not a professional speaker, but he's been trying to help me this last year to be a little bit more comfortable talking in public. Dan Quackenbush, he's the guy who I convinced to put the Intel NUCs on his credit card and to set vSphere up in his basement. And then lastly, John Wigan, who, if it wasn't for him, I would not be here today. So thank you.